Hi, and welcome to the third in a series of workflow guides that we are putting together to help FARO customers get the most out of their laser scan data. In this video, we will continue the workflow of bringing FARO scan data through FARO Scene and into Autodesk Revit when taking the data via Autodesk Recap. The first thing we will do is to pick up where we left off in the previous video, looking specifically at the import of scan data on a local coordinate system. We will then move on to look at how we can achieve a similar result but with scan data which is geo-referenced or on a site grid coordinate system. And within both of the above topics, we will also cover some of the basic project setup functions within Revit. Okay, if we move on now to look at some of this data inside Revit, the first thing I'm going to do is go to my project browser and open up the site plan. I'm then going to delete levels 0 and 1 as I'm not going to be using those. Okay, you'll notice in the centre of your screen now, you have a little circle with an X in it and a triangle. The circle is the project base point, and you'll notice as I move this, the coordinates update in relation to the survey point, which is the little triangle. Okay, now I really need to give you a quick basic explanation of the Revit coordinate systems. There are actually three different coordinate systems within Revit. The program's internal coordinate system, which it uses to define geometry and is not visible or editable. The second is the survey point, which is the triangle we looked at, which defines a known physical position in the real world and is used as the basis for linking multiple models by shared coordinates. This is going to be used to give our true north for the survey and anchors us in the real world. The third is the project coordinate system, or the project base point. This is used in this project only, so allows us to define a local coordinate system and orientation to make modelling easier. This could be anywhere in the project, on the grid line intersection or the corner of a building. It does not really matter where this is, and it's not really important. What's important is that we know the relationship to the survey point, as if we know this relationship for multiple models, we can align them. So in relation to our first project example, it's quite simple, as we are not really concerned with real world coordinates, as the project point cloud is not on survey grid or is not geo-referenced. In this case, I'm going to leave the survey point and project base point as they are, and I'm going to import the RCP file and position it origin to origin. This will position the XYZ000 that I set within Recap directly on top of the project base point, so in this way I'm controlling the position of my import. Now, because of the compass we have in the FARO X series of scanners, this scan is actually orientated correctly to true north, even though we have no specific separate GPS survey control data. Before we move on, if we quickly look at the visibility and graphics settings, if we scroll across the point cloud, you can see that the RCP file is actually referencing each individual scan. Now we can turn these off, or we can edit the colours on a global basis or a local basis for each individual scan. I'm now going to go to the Manage Links tab, and I'm actually going to unload the current scan that we have. I'm now going to bring in the unified scan of the isolated house, as this is a smaller file and it's going to be easier to model. The origin point of the scans are the same, remembering that we updated this in Recap previously and exported this particular file from the same overall RCP file. So I'm also going to bring this scan in origin to origin. If we quickly check the visibility and graphics settings and scroll to point cloud, you can see that we're now dealing with one single scan. So in this instance, I actually want to create an orthographic view to allow me to model things correctly and with ease. And I can do this by rotating the project north. I'm going to do this by going to the Annotate tab and drawing a line as close as possible to the front face of the building, which I'm then going to use to define the rotation angle. If I then go to the Manage tab, Position and Rotate Project North, I'm going to select the Align using the Selected Line or Plane function, and if I select my line, the Project North will rotate. I can then delete the line as I no longer have any use for this. The beauty of this method is now that I have a model orientated correctly in the real world. However, I can flip back and forth to the project north to do my modelling. Remembering that my actual scan data is already correct to true north, if I go into the view settings and change this view back to true north, I can reload my full scan back in and I can flip between the various orientations, as I will use this scan for the site context of my model later down the line. I know that a lot of our customers experience problems when using geo-referenced scan data or scan data that has been gridded to a site-wide system within Revit. The problems are often similar to this. If I bring in my geo-referenced point cloud data and I bring it in origin to origin, it appears to be miles away from where we actually want it to be. If I then go to cut a section through this data, it seems to be giving me the correct height information. This is because the base point elevation is currently set to 0. But in most cases, people will just then drag this scan to where they actually want it to be and start modelling. You will also notice that this data has been squared up. However, we want to be able to show it as is in the real world. So if we open up Revit now, the first thing I'm going to do is go to my site layer, and I'm then going to delete levels 0 and 1. I'm then going to just move the project base point in a clipped state to show you that the whole project relocates. I'm then going to hide the project base point just so I can get access to the survey point. And we really need to understand the difference between clipped and unclipped states. If we move when clipped, the origin of the shared coordinate system, that's the XYZ000, will relocate. However, lots of surveyors want to be able to show spot coordinates as they would be in the real world. So I'm going to unclip this survey point, leaving the origin of the shared coordinate system where it is, and when this survey point is moved, it will report values relative to this position. I'm then going to update this position to match one of the control points used during my survey. So for ease, I'm going to use the specify coordinates at a point feature and click the survey point. Note at this point, the east and west is going to match the x-axis of our scan, the north and south will match the y-axis of our scan, whereas the elevation will match the z-axis. And we will also need to know the azimuth of the survey so we can rotate back to true north and use the east and west selection rather than a negative number. I'm going to input the OSNet coordinates now, and the numbers I've been given have been reduced to only include 3 numbers after the decimal place. You must remember when putting these into Revit to miss out the decimal place. You will notice now that the survey point coordinates have updated. I'm going to click the survey point to lock the position and switch the view to Project North to show you that the global and local orientations are now different. First, I just need to unhide my project base point, and you will notice that as I move this, it is giving us coordinates which are similar to and relative to the survey point. And if I switch between Project North and True North, you will notice that the orientation of my view updates. However, as I know that the data I'm about to bring in has actually already been squared up, I'm going to make sure that my view is set to Project North. I'm now going to open up a second window showing some geo-referenced scan data in Recap, which I've clipped down to site level. Note that the coordinates in the bottom left corner of the screen are updating and are similar positions to my coordinate systems within Revit. If I go across to Recap now, I'm going to find a good position which I can use as my origin point. And this is going to help me make sure everything's nice and orthographic for ease of modelling. I'm going to go to the update origin command, which will reset the coordinates at that position to XYZ000. I can select the point and either press the escape key if I'm not happy or return to confirm. I also need now to make a manual note of the coordinates, and I'm going to transfer these across to Revit. If anyone from Autodesk is listening at this point, a nice little automated feature to do this would be really helpful. If I zoom this in to make sure I'm getting the correct point and press return, the coordinates will update. So I'm going to reset my clipping box, and then we could either do a save as or create a specific RCS export for this data in the new local coordinate system before we bring it into Revit. My preference is to export another RCS file, and while this is exporting, I'm going to use this time to input the global coordinates which were present at my new origin scan position into the project base point within Revit. I'll do another quick orientation check now, and I'm going to pause the video and restart it when the export completes. When I close down Recap, I'm actually going to do this without saving the changes, as I want to keep the original geo-referenced data. If I maximise the Revit window, I'm now ready to bring the scan data into Revit to use, and I'm going to go and find that RCS export and import it origin to origin. I now have scan data positioned and orientated inside Revit to shareable real-world coordinates, however set to a local coordinate system and orientated for ease of modelling. You will note if I cut a section through the data, the existing levels are referencing the local coordinate system, so the distance from the project base point. However, I can change these in the property dialog to show the distance from the survey point's origin, remembering that this is still at 0 as I unclip my point before I moved it. I'm just going to delete this level and create a new one to open up a floor plan, and I'm going to create a new floor within there just to show the coordinate system and just show proof of concept. So if I open up my floor plan and just quickly make a architectural floor, I can then go to the annotate tab and I can take a spot coordinate at any position, which is giving me a northern and eastern, which are the kind of numbers that surveyors would like to see. I can also then change this to also include height information within the properties dialog. If I go to the edit type and scroll to the bottom, I actually have the option to change the origin point that this coordinate is referencing. So if I change this to the project base point, the coordinates are now displayed in a local system relative to the position of my project base point. Similarly, I can also just drop a spot height in here. One note of caution using this method is that it is geared towards surveyors producing measured surveys as a deliverable and who like to be able to give real-world spot heights, etc. It is quite possible that your customer is going to link your file with others later down the line and therefore may not want to deal with these large coordinate systems so far away from the origin of the shared coordinate system. So it's probably best to check with the end user prior to embarking on a survey. Thank you very much for watching. I hope this workflow guide was useful for you. In the next video, we will look at some techniques, tips and tricks to model up FARO scan data within Revit.